So this is a bit. I could talk about all kinds of different things, but this is a presentation that I gave to Team 540 for the last season. I was with Team 540. This is, by the way, I'm Mike Geipel. Stuart's my son. I was with Team 540 for 3 years when his older brother Clayton was active with them. He was the build leader over there, and I noticed that there seemed to be a set of issues that seemed to come up every year, and it seems to be always centered around this notion of engineering complexity. Now, you always hear about the KISS principle. You know, if everybody really wants to follow the KISS principle, then we would have only simple robots in competitions. Well, guess what? We don't. Take a look at the robots. The rookie teams have simple robots, but nobody else does, and there are very good reasons for this. So, what's wrong with complexity? Let's start with that. I'm going to be using as an example telephones, just because it's an easy thing for everybody to follow up on. What's wrong with complexity? Risk. That's basically it. There's a risk involved in having a complex anything. It's harder to understand. More importantly, it's harder to communicate. If one set of folks are working on something over here, and another set of folks are working on something over here, and they don't agree, there are more opportunities for that mismatch to escalate into something really serious. It takes more resources. You need more people. It takes more effort. It takes for the people who are available. It takes more time. And this is the key question: can we complete in the time allotted with confidence that everything works? And that's I'll be returning to this topic multiple times. So you always hear, "Keep it simple, stupid." Is there anybody who has never heard this phrase? So, and the question is, if we value simplicity so much, why is it that most engineering problems are not solved in a simple way? And I'm going to try to, and since I have to do this twice, I'm going to see if I can advance this one. Because I have some notes I'd like to say. All right. So let's take a look at the, so every engineering project I've ever been involved with comes down to questions about what the features are that you want in your product. Now, think about a cell phone. How many of, when I was your age, this is going to age me here. When I was your age, I was told that I need to keep, actually the price had just gone up, I need to keep 2 dimes in my shoes. Now, the reason why is because nobody has cell phones, and there are payphones everywhere, and if for some reason I need to call home, it costs 20 cents. And the price has just gone up from 10 cents to 20 cents. It's a big deal. So you walk up to a payphone. There's no contactless time. There's no YouTube or anything else. Does anybody have a telephone, even at home, that doesn't have just a contact list? You do? I'm impressed because there are very few of them left. I mean, it's very hard. I went to buy the simplest phone I possibly could at Walmart, and even it had a contact list in it. I don't have much use for it on my landline, but there it is. I was able to enter the contact list. It's really, I mean, and so there was a time when I knew the telephone numbers of everybody of every friend I ever had. Chances are pretty good that most of you don't know that. You probably rely on your phone or your contact list to do it, and it's just and if you think about it, what happened was back then we had a monopoly, no competition. The focus of the phone was to provide a telephone connection between one group of people and another. So what happened? Ma Bell gets broken up. Now you have competition. what does competition do? Competition means that I have to be able to differentiate myself from someone else. And there were a lot of people who made simple phones, and nobody bought them because they didn't have Ma Bell on them. They didn't have AT&T on it. They started selling phones. The competitors were able to start selling phones when they were able to provide a customer with something that they wanted that the base phone couldn't do. And all of a sudden you had different ringer tones, you had different, you had the contact list. I remember when the first ones came out that had this, we called them Star Wars ringers because they had this really, because it wasn't actually a bell, right? I really am making myself on it. But I'm using this as an example because, let's see, can I get, what's the word? All right.
Click resume slideshow.
There we go. So, whoa, I didn't mean to do that. Pardon me, we were having some technical difficulties. So the things on the left-hand side are the things that are simple. Things on the right-hand side are the things that are complex. So a simple phone can make telephone calls. A simple robot can play the game. If you are a rookie team, your focus is to play the game. You're not focusing on winning. You're focusing on learning the game, making sure you can play. If you make sure that you can play the game, then you don't have to worry about making sure that you can differentiate yourself from others. But if you are looking for a way to seek a competitive advantage, you have to make your product more complex. This is the reason why the robots and phones are not really simple. Now, a simple product, why is it that simple is important? Because a simple product is easy to tell when it works. It's easy to tell when it's robust. It's easy to understand the modes in which it can fail. When you make it more complex, that's no longer your main goal. Your main goal is to find that something that you can say about your product that is a marketing issue about why your product is better than somebody else's. And in the realm of telephones, that's features. And the customers are the people who buy the phones. In robots, in robots, the focus is a little bit different, and I talk about something else. So when is it the robot is too complex? It's when you can't be sure that it works. And that really is that's the fundamental message of this part of the presentation I want to get across. You can make your product arbitrarily complex as long as you can test to make sure it works. I'm going to say it again. You can make your product arbitrarily complex as long as you make sure that it works and can be robust. If you can't be sure that it works, you've made it too complex. That's the litmus. That's the litmus test. We use it at work all the time. You know. For those of you who don't know, I'm an engineer. I'm the tech lead for a local group in the Richmond area. We're part of a company called Schneider Electric. We do HVAC kind of systems, and we build little boxes about yay big that control machines and the VAVs and so on, and rooftop units, and we have about 250 engineers worldwide that are working on our new project that we're working on, and my team works on one small part of the product that is kind of centrally. We support a whole bunch of others. We're part of the infrastructure team, and it's embedded software. It's embedded software in a box yay big. I should have brought one in to show you, and we also have one that runs on a PC. And when we decide what features we deliver, it's because we're going to have a test plan for what we deliver. And every time somebody says we've got to add this new feature, the first question is how do we test it? It's got to be your first question. So make certain that your design is testable. Test at every stage of integration. Now, I'm going to step away from this presentation. I wrote this presentation a year ago for a different team, but it's just as valid for this one. I think that in software we often talk about sprints, where we and in an environment like this one, you might have a 1-week sprint, which is where at the beginning of the week you decide what you're going to accomplish in that week, and you do whatever it takes to complete it. By the end of that week, you communicate to all the other teams what they can expect from you, and and at the end of the week you have a test plan and you have an integration step. Now, in an ideal world for robots, you can build 2 robots. Have one robot that in the first week the build team builds just out of the kit of parts if necessary. Just the simplest possible robot, but you can drive it. It's got a program, and then that robot that'll be your like your test bot or whatever. The programmers and drivers would get a chance to play around with it. You get feedback on how it works while the second bot's built, and then every week that bot becomes the new one that the drivers and programmers get, and the other bot gets taken apart and rebuilt to be the 3rd week bot, and so on. And then when you get to the 5th week, the 6th week bot becomes the one that you put in the bag. The 5th week bot stays for test and driver. Now, I understand there were some challenges this year, but I still think that that's probably the best way to approach it. It allows for a more incremental approach to design. You don't have to design everything up front. All right. And, oh yes, make sure your tests are repeatable. So, if you wait until the 6th week to do your first integration, I guarantee that the first integration you do is going to be a disaster. So if you wait until the 6th week to do that integration, that's the one that will be a disaster. So you need to make and I understand that we didn't get everything done before bag time, but if the goal is to get everything pretty much wrapped up by the time you get into the bag, it helps a lot if you can get these integration steps handled earlier. If you're running out of time, you can pull out features, but you never pull out tests. You don't ever cut corners on testing. And this means every team. This means programmers, it means CAD, it means electrical, it means build. Anything that you have, you need to write down. So all the wires should be labeled. There should be a checklist. I should be able to take the whole bot apart and put it together with just the information that's on the checklist. So this wire goes here, this wire goes here. This is the step that I do to make sure that the wire is actually connected. Do I use a fluke meter? Do I use some special diagnostic program? I don't know, whatever it is. But we should have all of these. Now, I'll give you an example that happened in Team 540, where they took apart. They had the bot working just fine. It was in the bag just fine. They get there on Thursday, and they had to mount something into the gearbox. So they had to take the wheels off and put it back on. Now, this is the year that they had Meccano. Now, what happened? And they could not figure out why it wouldn't work. Yeah. Now, my son happened to be the build lead. He knows he put it on right, but he's not the one who did it that time. He was working on a different problem, and so with Meccano, if you can look at it from the top and the tread makes an X, then you know you've put the wheels on right and 2 of the wheels reversed. Of course, they were blaming programming, they were blaming wiring, they were blaming everyone else. The point is, that is a failure of the whole team. It's not a failure of the person who put it on. He put it on exactly how he thought it was. I'll give you another example. Same sort of scenario, they had to pull some wires off the e-board. The guy who put the wires back in, he designed that e-board. He knew how those wires had to be. And he put them in exactly as he knew it was supposed to be. He was actually the electrical leader. What he didn't realize is that the previous time that it had been put together, it had been put together wrong, and the programmers had been asked to reverse the direction of the wires. This was
It's a nightmare.
It is a nightmare because the e-board guy was right, and yet because the wires weren't labeled, and there was no checklist to follow, and there was no way to validate that everything was connected end to end. It was a failure of the whole team, not just one person or one team. You know, it's got to be understood that every team needs to be responsible for finding out, for being explicit about exactly how everything needs to be put together. And I'm spending a lot of time on this. I'm sorry, but I feel passionate about this need because it happens all the time. It's not this team. It's not just this team. It's not just Team 540. I bet every single team that's made up of people who are, you know, who haven't spent a lot of time in industry are going to run into the same kind of problem, because, you know, we only have 6 weeks to learn everything there is to learn about being an engineer. You know, you're not going to learn everything, but you're going to find out that this is the #1 thing that can make a difference between success and failure. You're going to be in a situation here shortly, where on Thursday, where you're going to have to do a lot of stuff, and it is incumbent on you to think in advance what all that stuff's going to be and prioritize it and get it all in. And
You're disabled because
I am in the wrong screen. So, suggestions. These are the suggestions I made for Team 540, and it's just as valid here. Develop your project in phases. Don't try to design everything up front in the first week. We're not building a house. You don't need to have the perfect foundation before you put up the walls. That's the way you solve an engineering project if you're the only person working on the project. But you're not. You're a large team, and sometimes it makes sense in a large team that is as deep as this one to actually think about tearing up that foundation and putting in a different one. It makes, you know, do it in phases. You've got the manpower to do it, and it's the way you make a design incremental. Every team needs to think about what constitutes a test to make sure that their part of it is correct. In their case, I made a suggestion that they have a test lead. I should have actually named this something a little different. An integration lead. Somebody whose responsibility was to make sure that at the end of every week, or the end of whenever integration were to start, you know, all of the work stops on the bot that's going into integration, and they determine, okay, I've got the test documents from all the different teams. You know, the e-board folks, it needs to be wired this way. The build folks say that these are the things on his checklist, and so on. Programmers say this is the program to run, and these are the things you need to do to make sure that the inputs are right, and run through it. And he's not the only one to do it. He would just be the lead of folks to go through that, so that lots of people would get some familiarity with how to bring up a robot. And this was about the sonic field. Can you think of ways to do things in parallel? Can you think of ways to get one team working on something that doesn't cause something some other folks aren't waiting for? And this was brought about because of a problem they had. They didn't have actually a test bot in the same sense that you did. you do. So what they were running into was that the programmers would get access to the actual final bot, a few hours before it was supposed to go into the bag, and they didn't have another bot to work on after it went into the bag. This year, I think they've fixed that. But this was, that was, how to do things in phases. How to make, don't try to deliver everything at once. Try to deliver things in pieces. Integrate earlier. This is one of the most important things that I think you can buy into and get a lot of benefit from. Integrate earlier. Make sure that you get the feedback from the drivers, what the drivers need earlier, so that the program makes sense, so that the features on the bot make sense. We put I won't go too far into that. So here's a little question for you. This is going to ask for some input. Imagine for a moment that you were to divide. You come up with a backlog of all the things you want to get done, and you have things. And I know there are lots of variations in gray and in these categorizations. But imagine for a moment that you could say these things are important, and these things are not important, and some of them are urgent, and some of them are not urgent. If you were to look at this, and you were to try to decide how to fill the rest of this in, first, second, third, whatever, what do you think should be the answer? Ideas?
Put second in both important and not urgent, and in urgent and not important.
Okay.
Put them equals.
All right. I'm going to have to ask you to say which one of those two you would prefer. Sorry.
I put second in the bottom left and third in the top right and then fourth in the bottom right.
Yep. 1, 2, 1, 2, 3, 4.
So.
And Ron streaking.
Excellent. Actually, I'd go a little farther than that. Things that are not important, you don't do. No matter how urgent they are. Now I'm going to step back a little bit and tell you what the difference is between urgent and important. Now, understand that there's the challenge you're going to have is deciding where this line is in the scale of 0 to 1 and this line. Understand that this is probably the most important line you need to define. And it's not because of this box, it's because of this box. Urgent is defined as something that you need to do by a timeline. If you don't do this by, let's say you have to fabricate a part. If you don't do this by this date, then, and you need a 2-week spin to get something fabricated or ordered or whatever, then there's a cost. The cost is either you don't do it, you have to build it manually, or you spend extra money to get a fast return. That's what urgent means. Urgent means that you have a deadline, you have a timeline to meet. Important and not important, I've imagine for the moment that there are lots of different variations in important and not important. The important, and ultimately the things that are not important you don't want to, the things that are really unimportant you don't want to do. Things that are important you want to do. But the definition of this line is really critical, because if something is urgent, if something is not urgent and not important, and you don't do it, there's no harm. You can always choose to do it later. There's no cost to deferring it, because it wasn't urgent, right? But the things that you decide are urgent, they're cost to not doing now, but you decide are not important enough to meet that deadline. That's what's actually going to decide what your project looks like in the future. These are the things you decide to put in this box that you choose not to do, but that there was a cost to not doing. These are the things that will define what your project looks like. These are the decisions that you make that will affect what you actually deliver. Now, this is a hard thing to try to describe, but what I'm trying to get across here is that the definition of the most important thing that you need to do in any sort of engineering enterprise is to decide the things that you will not do. I guess that's what I'm trying to get at. You will always have more tasks to do than you will have resources to accomplish in any given time.
Where's Alex?
You will always have more. In my company, we talk about backlogs. We create a backlog with all these things: urgent, not urgent, important, not important. And guess what? The things that are not important at the time that you have to make the decision not to do them might have been thought of as being very important 2 weeks ago. These things have to be evaluated basically in every sprint. Every time you decide what you're going to do in a week. You decide the things that are the most important, and that order changes as your project progresses and as the features change. And at some point you decide, it's just not important enough. It's urgent, which means that because I don't do X, I can't do Y, but I'm going to live with that. And that's what I was trying to get at here. The key to prioritizing urgent tasks is to identify the ones you should not do. In engineering, we always talk about deferring decisions. You try to, because here's why. At the beginning of a project, you do not know what you're building. Even at kickoff time, you didn't know what this robot was going to look like. Even if you don't even know you don't even really understand the rules. The rules change. They get modified over time. Last year's a great example. There used to be the original plan. I think you could only go like 18 inches past the perimeter, and then they changed that to be something massive afterwards. Well, it made a big difference in what we ended up designing. We had to change our design because of that. At the beginning of a project, no matter what project it is, you don't know enough to know how to decide all the decisions you need to make. So what you typically do is you try to defer decisions that you don't need to decide right now as late as possible into the project where you know more. And that's where this thing about deciding the urgent things that you can't do comes into play. You'll always have more to do than you have time for. Always do the most important tasks first, and reevaluate all the time. And that's kind of preference in that, right? And that's it. Yes.
No, you have a slight heckler behind you.
Oh.
Who's saying goodbye?
Okay. Does anybody have any questions?
That was a very nice
Yeah.
slideshow. I like that.
I mean, if you're interested, I could when
I would love to try this one again about September.
That's exactly what H did. They decided to do it very early in the season.
This one would do very well beginning of the year. This is really good.
And at some other time, if you want me to talk about the work that I do, I could get into
Absolutely.
I could get into that too. But I think this is the thing that it's kind of late in the season, but think about it. This is.
We're still in process with some of this. We have mods. We have to decide whether we want to do them or not.
Yeah. Let's talk about the mods that you're gonna have to do on Thursday.
Well, let's defer that till later this afternoon when we have more information.
Okay.
I've asked
Sure.
these guys what mods are going to do and all. We're working on getting together with. They actually have an honest discussion of which ones are going to be valuable or not.
Right. Okay.
And that's going to have a lot to do with where you tell us where the programming is.
Okay. All right. Thank you very much.
Thank you.
Thank you.